Hello, good evening, everyone. You're welcome to today's Public Sector Accounting and Finance class. Today, we'll be looking at the topic investment appraisal in the public sector. And under that, we'll be looking at the methods of investment appraisal. Then, we'll look at discounted cash flows, not discounted cash flows for today's class. So, let's start with the first one, which is investment appraisal in public sector. Now, investment appraisal is a technique used to find out the least possible costs of an investment and the maximum benefit to be gotten from the investment. What is this saying? This is trying to tell us that what investment appraisal does is looking at a series of investments in which a company wants to make and taking the best one, the one they think will be the best for them, the one that is going to yield highest profitability, give them the maximum benefit. And you cannot just do this by looking at the investment at a glance. There are some certain calculations that you have to do for you to know which one will be more profitable, which investment you should embark upon, and which investment you should avoid. So having said that, we'll go to the method of investment appraisal. Now we have the non-discounted cash flow method, we have the discounted cash flow method, we have the investment decisions in government, and we have others. Under the non-discounted cash flow method, we have the accounting rate of return, the payback period, and under the discounted cash flow, we have the discounted cash flow itself, which is divided into two: net present value and internal rate of return. Then we have the profitability index. So discounted cash flow and profitability index are under discounted cash flow. While under investment decisions in government, we have the cost benefit analysis, cost effectiveness analysis. Then under others, we have our life cycle costing and our value analysis, also known as value engineering. So for today's class, we'll be looking at the first two, which is non-discounted cash flow and discounted cash flow. So we start with the first one, which is non-discounted cash flow. Now, what does non-discounted cash flow mean? One non-discounted cash flow simply means that the cash flow used in the calculation under this aspect will not be discounted. What is discounted? Discounted comes in place when you recognize the time value of money. Now, we all know that 10,000 naira of today is not the same with 10,000 naira of the next 2 years. What you can buy with 10,000 naira today is not what you can buy with 10,000 naira in the next 2 years. For example, you can buy a pair of jeans and shirts for 10,000 naira today. In the next 2 years, with that same 10,000 naira, you may be able to only buy a pair of jeans. You won't be able to purchase the shirt anymore, because the value of that 10,000 naira is no longer the way it used to be before. So, having that in mind, that the value of money today will not be the value of money tomorrow, that's where discounting comes in place. So accountants and financiers used to discount the money so they can get the value of the money in the future. They want to get the value of 10,000 naira now in the future. What will 10,000 naira now be worth in the future? Most likely 10,000 naira now in the next 1 year may be worth 9,500 or 9,000. That is what you can use 10,000 naira to buy now. By next year, you can only use that 10,000 naira to buy something worth 9,500, because the value of 10,000 naira would have dropped to 9,500. So that is what discounting means. Now, when we say non-discounting cash flow, it means that this method, under this non-discounted cash flow, they take the cash flow as it is. If you are telling the manager that this investment you are expecting to get 50,000 naira next year, 20,000 naira next 2 years, they take the value exactly the way it is. They take the 50,000 naira exactly the way it is. They take the 20,000 naira exactly the way it is, and that's what they use in their calculation. They don't discount that money, taking they don't discount that money. You understand? They don't discount the money using discounting factor and recognizing that the time value of money is in effect. That is, money depreciate over time. Okay, so we'll look at the first one, which is accounting rate of return, and this method is used to know the rate, just like the name implies, accounting rate of return, the rate of return you are expecting on any investment you make. That's what accounting rate of return does. It enables you to get the rate of return you are expecting on a particular investment, and it has a formula. The formula is average accounting profit over average investment. Sorry, the material, I think there's a mistake somewhere. ARR is supposed to be, ARR is equals to average annual accounting profit over average investment. That's the formula, average annual accounting profit over average investment. The corrected one will be in the material that will be sent to you in the group chat. Average annual accounting profit over average investment. That is how we get our ARR. And how do we get our average annual accounting profit? Our average annual accounting profit is simply summing up the profits that I will be giving to you in your question. If they give you 7 different profits, add the 7 profits together, divide it by 7, you get your average annual accounting profit. Then the average investment is calculated by adding your initial investment plus your residual income and dividing it by 2. Okay, now what is the decision rule? After you've calculated the accounting rate of return, what decision will you make as an investment appraiser? What decision will you tell the manager to take concerning that particular investment? Now, you always take the investment that has the highest accounting rate of return. Any investment that has the highest accounting rate of return is what you should pick, because when they will give you your question, they will most likely give you 3 different investments or 2 different investments, telling you using ARR. Tell the manager, advise your client on which of this project should be embarked upon. So once you do your calculation on your ARR, the one with the highest is the one you will advise the client to embark upon. Now, what are the advantages of ARR? The first one is that it is simple to calculate and understand. The formula is very simple, average annual accounting profit over average investment. So it's very simple to calculate, it's very simple to understand. Anybody can do it. Then number 2 is it considers the profit of a project throughout its useful life. It adds up all the estimated profit that you want throughout the estimated profit of that particular investment throughout its useful life. Let's say you are supposed to buy a machinery, and the machinery is going to last for 4 years, and that machinery is going to give you profit of 10,000, 8,000, 3,000 and 7,000 for the respective years. You are going to use the profit from all those 4 years. You are going to add them up together, divided by 4. So you are considering the profit for the whole useful life of the project in making your decision. Then the disadvantage is that it does not consider the time value of money. Just like I said earlier on, the money worth today, what money can buy today is not the same thing that same value will be able to buy in the next 3 years. So this method does not put that in consideration. They don't discount their money. The cash flow that they are expecting in the next 2 years, they don't discount it to know the present value as at now. So that is a disadvantage of it. Then number 2 is it ignores the fact that profit from different projects may accrue at an uneven rate. So we have a question here. The question says, Agbede Local Government Council supplied the following information. The projects, we have project 1, project X1, project X2 and project X3. Our profit figures for year 1 is 1,500 and 5,000 respectively. We have for year 2, we have for year 3, year 4. Now we have our initial investment sum. The amount they initially invested in each of the projects is given to us. Then the residual investment is given to us, which is 1,000, 1,000, 2,000 naira. So in this question, we are asked to advise the local government council on which project to be invested, which project should they invest on. That's what we are asked to do here. We're going to look at using ARR. So we're going to look at the calculation of each of the projects. The one with the highest ARR is what we advise them to embark upon. So I haven't done that. We go back to the question. So we have our solution now. We have our solution. Okay, our solution, look at it follows the formula, which is average annual accounting profit over average investment. Then they've gotten their percentage. But how did they get to this point? We are going to solve that now. Let's go back to the question. So in the question, I'm just going to solve for project X1 for us, then we solve our X2 and X3 by ourselves when we get the material. Just want us to get a clear picture on how to solve the question. All right, the first thing we should get is our average annual accounting profit. And what is our profit in project X1? Our profit in project X1, we have 1,000, we have 2,000, we have 4,000, we have 5,000. By the time we add this up together, we have 12,000 naira. Now remember I told us that you will add up your profits for the years given to you, then divide it by the number of years. So for project X1, we've gotten that our total profit for project X1 is 12,000 naira. But how many years are we going to use to gather up this 12,000 naira? We are going to use 4 years. Therefore, our average accounting profit will be what? 12,000 over 4, which gives us 3,000. So this is our average accounting profit. So we've gotten our average accounting profit. The next thing for us to get is our average investment. How do we get our average investment? I told us earlier on, it is initial investment plus residual value over 2. And the question gave us our initial investment for project 1 as 15,000. Our residual is what? 1,000. So you add it up and divide it by 2. That will give us 16,000 divided by 2, which is equals to 8,000 naira. 8,000 naira. So we've gotten our average accounting profit and we've gotten our average investment. The next thing for us to do is to calculate our ARR, and our ARR is average accounting profit over average investment, which is going to be 3,000 over 8,000. And if you look at our solution here, we can see that was what they did, 3,000 over 8,000, and that's how they got 0.38, which is 38%. So they solved the same, this just the same way we solve for project X1, is the same way we solve for project X2, and we solve for project X3. And as you can see, we have 38%, 30%, and 31% respectively. So you are going to advise the local government to invest in project X1 because it has the highest accounting rate of return. So having done that, we move to the next non-discounted cash flow method, which is what? Payback period. Now, what is payback period? Payback period is simply just calculating the time it takes for an investment to recoup the amount of money that has been put into the business. For example, you invest 1 million naira into a particular business. How long will it take you for you to get your what? 1 million naira back? That is what payback period is concerned about. How long it will take for you to what? Recoup your investment in it. Now, this method too does not take into consideration the time value of money. So what's the decision rule? Decision rule is to accept the project with the shortest payback period. Whatever project it is that is going to make you recoup your money faster. If you have 3 projects, project A, B, C, and project A, you will recoup your money in 1 year. Project 2B, you will recoup your money in 1.5 years, and project C, you will recoup your money in 6 months. You'll be advised to invest in project C so that you can get your money back, because you are getting your money back quickly. So having said that, we'll move to the advantages of payback period. It is simple to calculate and understand, and it is a useful measure of liquidity. And it is a useful measure of liquidity because it ensures that the projects you are selecting provide hope for immediate cash recoupment. Because with this calculation, you are giving yourself hope that you are going to recoup your cash immediately. So it is a useful measure of what? Liquidity, and it's a useful screen to evaluate all projects. Disadvantages: it does not consider time value of money, and cash flow outside the payback period are ignored. Once you've recouped your money, they don't take into cognizance the cash flow that is going to come again from the project. Let's say the investment, you're investing in a machinery that is going to last for 4 years, and your cash flow, you're able to recoup your investment in year 2. The cash flow you get for year 3 and year 4 is not really important in the calculation any longer, unlike ARR, where we add up all the cash flow from the life span of that particular investment. So we also have another question here. Omido Local Government Council is considering investing in one of the following 3 available projects. Using the payback period method, advice on which of the projects should be selected. We have our project B1, project B2, and project B3. We have our initial investment outlay. For B1, we invested 100,000. For B2, we invested 150, and for B3, we invested 180,000. Now let's look at B1. In year 1, you recoup how much? In year 1, you are expecting to recoup what? 70,000 naira. In year 2, 30,000 naira. In year 3, 20,000 naira. And in year 4, 10,000 naira. Now, if you invested 100,000 naira in year 0, that's your initial investment. In year 1, you have gotten 70,000 naira. How much of your investment is still left in the business? It will be left 30,000 naira, because 100 minus 70,000 is 30,000 naira. In year 2, you gain 30,000 naira again from the business. How much of your investment have you gotten back? You've gotten back your full investment back, because before it was remaining 30,000, and now you've gained what? 30,000. So in B1, it takes you exactly 2 years to get back your what? Investment. Let's look at B2. B2, you invested 150,000 naira. In year 1, 10,000 naira. You got 10,000 naira. That means you are left with 140,000 to recoup. In year 2, 20,000 naira. That means you are left with 120,000 naira to recoup. In year 3, you got another 10,000 naira. It means you are left with 110,000 naira to recoup. In year 4, you got 40,000 naira. It means you still have 70,000 naira to recoup. That means for project B2, in the 4 years, you won't be able to recoup all your investment. Let's look at project B3. Project B3, your initial investment is 180,000. In year 1, you were able to recoup 50,000 naira. How much is left? 130,000 naira. In year 2, you recoup 60,000 naira. So how much is left for you to recoup? It will remain 70,000 naira. In year 3, you made 80,000 naira. So your 80,000 naira has been able to cover up your what? 70,000 naira that is left for you to recoup. Now, since is the money in year 3 is excess, it was remaining 70,000 before, and in year 3 you made 80,000. That means you cannot say that the payback period is 3 years, because there's part of that money, because you were able to recoup your money before year 3, before we got to year 3. That is, you're able to recoup your money between year 2 and year 3. Unlike B1, where at exactly year 2 we recoup our money. So whenever you have an amount that is rolling over, let's say for example you have 80,000 to recoup, and that's, let's say, the 5th year, for example, you make 100,000 naira. You will not say that you made your payback period is 5 years. Your payback period will be 4 years and some months. 4 years and some months. Like for this place now, your payback period will be 2 years and some months. And how do we calculate these 2 years and some months? We calculate it simply by taking the initial amount left. Like in this B3, I said that year 1, when we remove 50,000, we are left with 130,000 to recoup. At year 2, when we remove 60,000, we are left with 70,000 naira to recoup. So you take that 70,000 that was left to recoup at year 2, then you divide it by the amount you got in year 3, which is 80,000. By the time you do that, you are going to get 0.875. 0.875. That's what you are going to get, 0.875. So you recoup your money in two years. This 0.875, you cannot put it like that because it is not in months. So you have to convert it in months. How do you convert it to months? You simply just say 0.875 times 12. By the time you multiply it by that, we have 10.5. So you can say you recoup your money in 2 years, 10 months. In 2 years, 10 months. It's either you do that, or you just write 2.88 years. You can either write 2.88 years, or you write 2 years, then you convert that 0.888 to months, which will be 0.88 times 12 months, which will give us 10 months. So you say 2 years, 10 months. I hope we understand. So the first one, we recoup our money in 2 years. The second one, we could not even recoup our money throughout the lifespan of the project. Then the third one, we recoup our money in 2 years and 10 months. So you will advise them to select what? The first project, because it recoup his money in year 2. Alright, having done that, let's look at their solution. Okay, look at the solution. We have the 100,000 less 70,000, like I said. We have 30,000. Then we less 30,000, we have nil. It's just what I explained. Then they said from the appraisal conducted, Project B1 was able to pay off his initial capital injected in year 2. B2 could not generate enough cash flow for the period of 4 years. Project B3 made its own in 2.88 years approximately. This place they use 2.88 years. So you can either use 2.88 years or use 2 years, 10 months. Therefore, B1 is therefore more profitable than B3, and B2 should be dropped completely. So having said that, we move to the next type of what? Investment appraisal. So we are done with the non-discounted cash flow method. So we are moving to the discounted cash flow method, and this discounted cash flow method takes into respect the time value of money. Like I said before, we have 2 types of discounted cash flow. We have our NPV, which is our net present value, and we have our IRR, which is our internal rate of return. Now, our net present value involves getting the present value of a project by discounting the cash inflow and outflow from the project. Now, whenever you are given this question and you are asked to calculate the NPV, a cost of capital will be given to you. Or a discounting rate, which is what we use to what? Calculate. Now, all you need to do is what? You use that particular rate given to you to reduce the value of the money. You need to discount the value of the money, because the value of 10,000 naira now, like I said before, will not be the same value with 10,000 naira in 3 years. Now, what is the decision rule? The decision rule is whenever you've calculated your NPV and you have a positive value, you accept the project. But once you have a negative value, even if your negative value is -1, you tell them not to accept the project. What are the advantages? It takes into cognizance the time value of money, and the cash flow of the entire project life are taken into consideration, just like ARR. Now, disadvantages: cash flow may not come as predicted. Everything is based on prediction. You are expecting the machinery, although they are well studied calculations and research that are done to generate this cash flow, but still it may not always come as predicted. So that's the disadvantage. You may be expecting to get 10,000 naira yearly from that particular investment, and there may be variations. Maybe a year you get 10,000, another year you get 8,000, another year you get 9,000. So that's what they mean by cash flow may not come as predicted. And number two, it is difficult knowing the appropriate cost of capital. Like I said, in solving this question, we have to make use of what? Cost of capital, which will be given to us in the question. But this cost of capital, for us to get the particular rate to discount our money, is usually a bit technical, and knowing the appropriate cost of capital to use needs a lot of research and scientific knowledge. Will I say scientific knowledge? Sorry, financial knowledge. So it is difficult, unlike ARR where you don't need to put all those things into place, or payback period. So it is difficult to calculate. Now we have a question. So with this question, I'm going to show us how to calculate our NPV. Now they said the following are the information provided by Yabu's local government council. Using the net present value method, advise the local government council on which of the projects TMX is the most viable and should be picked. So we have project T, we have project M, and we have project X. So we have our cost of investment, which is 100, 180, 150 respectively. Then we have the income we're expecting, the cash inflow we're expecting from the project from year 1 to year 5 respectively also. Now they said assume that the cost of capital is 10% using the discount table below. Now in this question, they've given us the discounted value. In this question, they're giving us the discounted value, which is for year 1 0.9090, year 2 0.8264. But in a question where you are not giving the discounted factor, as long as you are giving the cost of capital, which is 10%, there's a formula you can use to get these figures here. And our formula is simply 1 over 1 plus r raised to power n, or 1 plus r raised to power minus n, whichever you think is easy for you. Now how do we do it? Our r is our cost of capital and our n is the number of years. Okay, so for year 1, our year 1 will be 1 over 1 plus our cost of capital is 10%, which will be converted to 0.1 raised to power. For year 1, we're calculating for year raised to power 1. So by the time we calculate it, that will be 1 divided by 1.1 raised to power 1. You will see, if you are trying it with your calculator over there, you will see that you got the same value, which is 0.9090. The same thing with year 2. It will be 1 over, this place will change to 2. So it will be saying, you will see, you will get your value, which is 0.8264, and so on and so forth. That's how you do for year 1, year 2, year 3, year 4, year 5, to the number of years asked by you to calculate in the question. But this question made it easy for us. They've already calculated the discount factor for us. So the only thing they are expecting us to do is to calculate the NPV. And how do we calculate the NPV? It's simple. You just follow this format. You have your year, your cash flow, your discounting factor, which is your cost of capital, then you have your present value. Now for year 0, which is our investment year, for project T, we invested 100,000, and since it's an investment, it means money is leaving the business. That is, it is a cash outflow, so it will be in bracket, which represents negativity. Now our discount factor is 10%, which is our cost of capital. Now at year 0, our discount factor is always 1. For year 0, our discount factor is always 1. And why is this so? It's because anything raised to power 0 is 1. Like now, I told you the formula of getting our discount factor is 1 over 1 plus r raised to power n. Now let's say our n is 0. So we have 1 all over 1 plus 0.1 raised to power 0. If you punch that in your calculator, you see that you will get 1. So at year 0, your DCF is always 1. Now, you are going to multiply your cash flow with your DF. Now, your cash flow is 100,000 negative. 100,000 negative multiplied by 1 will still give us negative 100,000, which is what we have here. So we'll move to year 1. Year 1, we have 40,000 receipts, so it is going to be positive. Year 1, we have 40,000 receipts, which is going to be positive. Our discount factor is already given to us in the question, which is 0.909. You remember, if you are not giving your discount factor in the question, you use that formula I gave earlier on to calculate it. So 40,000 times 0.9090 is going to be what? 36,360. You can see that the value has dropped. What this thing is telling you that if the value of money is discounting by 10% using cost of capital of 10%, 40,000 naira today will be worth 36,360 naira in the next 1 year. Okay, we'll move further. We'll go to year 2. Year 2, we're expecting 50,000. Discount factor is given to us as 0.8264. By the time we multiply that, we are going to have 41,320. We can also see that the value decreased. So you do like that for your year 3, year 4, year 5. Then once you are done, you sum up your PV. So under our PV, for year 1, we have negative 100,000, which I calculated for us. For year 2, we have 36,360. For year 3, we have 41,320. For year 4, I did not calculate that for us, but I've already told us how to calculate it. So we have 45,078. For year, okay, this is for year 0, 1, 2, 3. Sorry. Then for year 4, we have 47,810. Then for year 5, we have 49,672. By the time you sum it up together, remember this one is in negative, so this 100,000 will be subtracted from the rest. So we have 120,240 naira, which means, and it is a positive figure. So you tell the local government to accept the project. But in this question, you are giving 3 different projects. So when you are giving like 3 or 2 projects, they want you to compare between those projects. So you calculate for project M, calculate for project X. So the one that gives the highest amount of NPV is one that you ask them to embark upon. So let's look at the solution. You can look at the solution here. Look at the format. We have our year, we have our cash flow, we have discount factor, we have our DCF. Now all this material will be made available to you at the end of the class, so you can go through it to get more understanding and try to solve the questions on our own. So we'll move to the next one, which is internal rate of return. Now internal rate of return is simply just you calculating the cost of capital that will make our NPV 0. It's just for you to calculate and get a rate, and when you get that rate, at that rate your cost of capital will be what? 0. So we have our formula here, which is R1 plus R2 minus R1 all over P plus N, where our R1 is our positive rate, our R2 is our negative rate, our P is our positive NPV, our N is our negative NPV. Now, what is the decision rule? What if you have calculated your IRR? Once your IRR is greater than the company's cost of capital, you accept the project. Once your IRR is greater than the company's cost of capital, you accept the project. And 2, if you are comparing 2 or more projects, like the previous question we saw, where we're comparing between project T, project M, and project X, you are going to select the one with the highest IRR, just like the previous question when I said you select the one with the highest NPV. But where NPV figures are usually in naira or dollar, whatever currency is given to you in the question, IRR are usually in what? Percentage. So we have a question here. Now, okay, looking at the formula, you can see positive rate, positive NPV, negative NPV. What does this mean? This means that in IRR, you are going to solve your question using 2 different discount rates. Unlike NPV, where we just used one discount rate, which was given to us in the question, 10%. In IRR, we are going to make use of 2 discount rates. Now, the 2 discount rates may or may not be given to you in the question. In IRR, you can assume any discount rate you want. Any discount rate can be assumed. You can use any discount rate you want. Or like NPV, where the discount rate has to be given to you in the question. IRR, you can use, if they give you just one discount rate in IRR question, you can assume another discount rate to be the second IRR, the second discount rate. Now, when we say positive rate and negative rate, remember in the previous one I told us that when you are calculating your NPV, once you get a negative value, you are not to accept the project. But when you get a positive value, you are to accept the project. Now, the higher your discount rate, the more tendency for you to have a negative value. The higher your discount rate, the more tendency for you to have a negative value. So if your question is given to you, and probably the question gave you 10% as discount rate, and they said you should find the IRR, and you now use 10% to calculate your NPV, because in IRR we are going to calculate NPV. You can see from formula we have positive NPV and negative NPV. You now use the 10% to calculate your NPV, and you got a positive figure. You are going to look for another IRR that you will, another discount factor, that is another cost of capital that you will use to solve that same question, that but will give you a negative NPV. Now, if you had used 10% before, and I said the higher the discount rate, the higher tendency of having negative value. That means you will increase your cost of capital. You can increase it to 15%, you can increase it to 20%, you can increase it to 25%, so that you will get your what? Negative value. And if it was the other way around, probably they gave you 10%, and when you solved with 10%, you got negative value. So you will reduce the cost of capital so you can get a positive value, because you need a positive NPV and you need a negative NPV to solve this question, to get your IRR. So if you're giving 10% before and you got negative NPV, you will reduce it to maybe 5% or 7% for you to get positive NPV. So let's look at the question so that we have more understanding on what I've been trying to explain since. Now we have Psaf Airways Authority is preparing the capital budget for the forthcoming year. 3 mutually exclusive projects are being considered. The projected performance of each of the projects are as follows. We have our initial cash outlay, that is our investment. There for each project, we have our inflow of cash. Excuse me. We have our inflow of cash. Now, they said the authority cost of capital is what? 10% per annum. They're giving us one cost of capital. Now, they said as the management accountant of the Airways Authority, advise on the desirability or otherwise of choosing any of the 3 projects using the internal rate of return method. They're asking you to use IRR to advise. Now, they said the following discount factor table is applicable for use. Now, you can see that we have 2 costs of capital here. We have 10% and we have 15%. And they've given us our discount factor. Remember, I told you it's not every time they will give you your discount factor. You may have to calculate it yourself. And also, it's not every time they will give you the second cost of capital. Or like this question where they gave us the first cost of capital, 10%. They also now gave us another cost of capital, 15%. It might not be the case. Sometimes they may only give you 10%. So, advise to solve that 10% first. Then what your value, whatever NPV you get, will not decide on whether you should increase the cost of capital or you should reduce the cost of capital. Remember, if it is positive, you increase the cost of capital so you can get negative. And if it is negative, you reduce the cost of capital so you can get positive. So having said all this, now what we just need to do now is to just calculate NPV the same way we calculated NPV before. But we are going to calculate for the 2 projects. That's what we are going to do. We are going to calculate for both the 10% and we are going to calculate for the 15%. Now, after we've calculated for the 10% and we've calculated for the 15%, we will now apply this other formula that was given to us here. So let's look at their solution. Okay, let's look at the solution. I'm just going to look at the solution for one of the projects, which is project A. You can see you can see for project A, look at the discount. They using 10% discount factor. They solved it the same way we solved our NPV, which is our year, cash flow, discount factor, and our present value. You can see at year 0, your discount factor is 1. I told you at year 0, our discount factor is always 1. Then you have your year 1, year 2, year 3. You multiply it, you get your answer, you calculate your NPV. You can see here that our NPV is positive. And because it is positive, that means this other one that is higher will give a what? Negative NPV. So using 15%, we still discount the same way. You can see we have a negative NPV now of 15%. Then we'll now come and apply our formula. And our formula is R1 plus P R2 minus R1 all over P plus N. And our R1 is our positive rate. What is the rate that we used that gave us positive NPV? Looking at this, you can see that it was 10% we used that gave us positive NPV. That is why they wrote 10 here. Then plus our P. Our P is our positive NPV. What's our positive NPV? 285. Open bracket. Our R2, and our R2 is our negative rate. What rate did you use to give you negative NPV, which is 15%? 15%, not 15, not this 15 naira. It's the 15% that you got. They said rate minus our R1. Our R1 is our what? Positive rate, which is 10%, all over our P plus N. Our P is positive NPV and N is negative NPV. So our P positive NPV, which is 285, then plus negative NPV, which is 15. By the time you calculate that, you're going to get your IRR, and our IRR is what? 14.75%. So you do that for all the projects. Then the one with the highest IRR is the one you advise them to take. So from here, we can see that for project A, our IRR is 14.75. For project B, our IRR is 14.85. And for project C, our IRR is 13.86. So you advise them to go with project B, which has the what? Highest IRR. So having done that, we'll look at the last factor under discounted cash flow method, which is profitability index technique. And what this does is it just compares the present value of cash inflow with the present value of cash outflow. And the formula is simple. The formula is, we have two formulas, but it's either you use the first one or you use the second one, whichever one is present to you. It depends on the question. Now, the first one is present value of cash inflow over present value of cash outlay, while the second one is net present value of cash inflow over present value of cash outlay. Now, what is our decision rule? Our decision rule, if you are using the first formula, which is present value, the only difference between the first formula and second formula is the first formula is present value, while the second formula is net present value. So if you are using the first formula, which is present value, you accept the project if the answer you got is greater than 1 and is positive. If the answer must be greater than 1 and it must be positive. If you have 0.4 positive, you do not accept the project because it must be greater than 1. But if you are using formula 2, that is the one that has net present value, as long as it is positive, you accept the project. So even if your project is 0.02, you accept the project. But your project, okay, so that's that about that. Now let's look at this question, which is the last question we'll be looking at today. We have is this the question? Yes. We have Ajiboye local government, in an effort to boost its revenue base, decided to acquire a tractor that will be hired out to farmers at affordable charges. The tractor will cost 600,000. That's our initial outlay, and the cash inflow is 180,000 for 6 years. The cost of borrowing to procure the tractor is 10%. Using profitability index technique, we are asked to advise them. Now, if you look at it, in this question also our discount factor is given to us. So let's go straight to solve the question. It's still the same thing with, basically we are just doing similar things, just little changes. So you just simply calculate your NPV, which is the same thing we calculated before: our year, our cash flow, our discount factor, and our present value. By the time you look at it at year 0, your DCF still remains 1. I told you at year 0 our discount factor is always 1. Then at year 1, remember they told you your inflow is 180,000 for 6 years. That means 180,000 is steady. There's no change in the value. That is why we have 180,000 from year 1 to year 6. Then we impute our discount factor, we multiply it, and we get our net present value. And since we got our net present value here, we are going to be making use of formula 2. So we have our net present value of cash inflow over the value of cash outlay. Now, what is our net present value? Our net present value of cash inflow is 183,936. 183,936. Then you divide it by your present value of your cash outlay, which is 600,000. By the time you get your answer, our answer is 0.31. And since we used method 2 and our answer is 0.31, I remember I told you in method 2, as long as your answer is in positive, you accept the project. But if it was method 1, which is using just the present value of cash inflow, as they did here, they used method 1. They calculated just the present value of cash inflow all over the present value of cash outflow. That is why they got 1.31. And when they got 1.31, because it is greater than 1 and positive, they accept the project. So whichever method they are using, you will still arrive at the same conclusion. So what are the advantages? The advantage is that it recognizes the time value of money and is consistent with wealth maximization principle. And disadvantage is that it is not so popular. This method is not really popular. You will not come across it in many scenarios, especially in public sector. So having done that, in our next class we'll be looking at the investment decisions in government, and where we have our cost benefit analysis, cost effectiveness analysis, and we'll be looking at other methods of investment appraisal, which include life cycle costing and value analysis. Thank you very much. Have a good day.